When contemplating the possibility of other life in the universe, the main starting point for any star system is, well, its parent star. First and foremost, for life to be possible in a star system, the star itself must allow for it. There are many that do not. For example, giant stars that simply don't live long enough for life to arise before they explode as supernovas. And while there are exceptions, very odd but still habitable zones such as those around pulsars, most stars that are considered to have habitable zones fall into several classes of stable star, but the life that might arise at these stars may evolve very differently from Earth due to the conditions these stars present to their habitable zones. The first class is the ubiquitous red dwarfs, the Type M stars. This class has advantages and disadvantages for life. On the one hand, they are the most abundant stars in the Milky Way by far, offering billions of chances for life in this galaxy alone. Secondly, they are very long-lived, allowing life a comparatively enormous amount of time to arise and evolve, far longer than what we have with our own sun. But they can also be violent stars, especially when young, producing giant flares and radiation that may make any planets within their habitable zones unsuitable for life. Also, they are small stars with habitable zones that are very close in. This creates a situation where planets within those zones could be tidally locked, meaning one face of the planet always faces the star. This could create a very different kind of habitable world than Earth, sometimes called eyeball worlds. These planets could have intense desert sides that are permanently baked by the star, but also a side permanently in the dark. At the twilight edge, there could be a zone where liquid water might be present, and if the atmosphere is active enough, might transfer heat to the dark side of the planet and allow for water there as well, and possibly life that may well be adapted for low light or completely dark conditions. Given that Earth has produced bioluminescence, one wonders what life on an eyeball world might be like. But in the end, the habitable zones around red dwarfs are probably not ideal locations for life to arise, but it also doesn't seem entirely impossible, and there's always the question of liquid water zones beneath shells of ice, like our own Europa, which could allow life to arise under the protection of that shell. And given the longevity of red dwarfs, they may prove useful for spacefaring civilizations looking to colonize very long-lived stars, and thusly may be attractive for SETI searches. The next class of star may be the most hospitable for Earth-like life, even more so than our own Sun. They are the slightly larger Type K orange dwarfs, and have several advantages over the red dwarfs. One, they too are a common type of star, though not as common as the red dwarfs. They are also a bit larger and brighter, so the habitable zone for these stars lies further out, favoring life because close proximity to a star is generally not good. And they live significantly longer than our own Sun, providing evolution and life more time to develop and evolve. These kinds of stars could be garden spots for life, providing longevity, stability, and a good habitable zone so far as we know. It's difficult to imagine a place that might be better for life than our own solar system, since we know a star like the Sun can produce life in a civilization. But the orange dwarfs might be better for that than the Sun, and it's possible that our star is an outlier that alien scientists might dismiss as unlikely to produce intelligent life. Yet our Type G so-called yellow dwarf star did exactly that, though it emits more green light than any other visible light, and it's actually rather large as far as stars go, more like a giant than a dwarf. So what other Type G stars could do it? Well, Sun-like stars are certainly of interest to SETI, but we don't really know how slow or how fast evolution can occur. If it occurs slowly in general, then Earth got lucky in producing intelligence, and then Sun-like stars will drop in likelihood for hosting intelligent civilizations. After all, ours won't be hosting it forever. The Sun's luminosity is increasing, and it will slowly bake Earth long before it reaches its red giant stage. But there is also the possibility that evolution could produce intelligence much faster than it did here on Earth. If that's the case, then the Type F stars come into question. These stars are larger than the Sun and live a bit shorter of a lifetime, but generally speaking, still billions of years. These stars are powerful. They would bathe their planets in ultraviolet light, but their habitable zones would be further out. And they have raised eyebrows before. The infamous KIC 8462852 is an F-type star, and the possibilities regarding their habitable zones are not well explored, but they are a maybe. But going into stars larger than this class, we start to run into the brick wall of instability and short life, and supernovas. But that also offers a possibility. Given that those stars tend to go supernova, which can pose a threat to a civilization, what happens if you see a galaxy devoid of these kinds of stars? What if a galaxy is detected that trends towards redder, more stable stars and has almost no blue stars? This concept is known as a red spiral, a galaxy that lacks these stars, and there are candidates for this. Natural explanations are on the table, of course, and are more likely, such as dust blocking certain wavelengths of light, but just maybe someone might have removed their dangerous stars. As an aside, after just over 2 years, this channel is getting big, far larger than I ever expected when I started it in 2016. That's thanks to you, the universe's greatest audience, so thank you. Throughout this YouTube odyssey, I've had a lot of people ask me, how do I make my videos? What's the process? How do I edit the videos? How can others create content on YouTube? And the answer is research and learning, as in everything I do on this channel. A lot of it. And it wasn't always clear and easy how to improve production quality. There was a lot of trial and error. But subsequently, I found something better, Skillshare, the best resource I've found for learning how to create content like this, link in the description below. They have a wide array of relevant courses you can take that covers anything from creative writing, filmmaking, editing, photography, videography, but also business, technology, and even lifestyle, including teaching. Essentially everything I needed to create this channel, but in one convenient place taught by some of the best and brightest in their fields. But it's not just for people wanting to create content. It's for the curious, which is why we're all here on this channel, including me. How about courses on crafts, languages, health and wellness? How about the culinary arts? I've actually considered doing a completely different kind of channel one day. How about a food channel? Not sure I'll do it, but if I do, I'll start by going to Skillshare to help adapt my skills before I even begin, and of course, learn something new in the process. Knowledge is invaluable, but you already know that. But it can be made easy to find, which is what Skillshare does. By following the link in the description, the first 500 people to sign up via the link will get 2 free months of Skillshare Premium to check out. And if you want to create content, there is no better time than to start now. Check out Skillshare today. Thanks for listening. I'm futurist and science fiction author John Michael Godier, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.